Hi, ladies and gentlemen. All right, so our plan for today is to go over a few practice problems that we have in the midst of your packet on verifying or proving identities. Before I go through those problems with you, I want to just kind of highlight some of these suggestions we have at the probably in the page before about advice for proving these identities. So the key thing for you to understand is that some of this advice, it'll help sometimes. It's not going to be perfect, but that's because every problem is a little bit different while still applying the same general goal of trying to get one side of the equation, the identity, to look like the other. Okay, so they're different identities take different strategies, so the only way to get better is to practice. And the other thing I'll just say is the only thing that's going to help is if you try. Okay, so the key thing is to just try something out. So the first thing is look for Pythagorean identities. So if you see anything, that's squared, that might be a hint that, hey, I might want to use a Pythagorean identity, cosine squared, sine squared, that sort of a thing. Now, suppose everything's to the first power, or maybe you've got a couple of fractions, then you might need to do some algebraic manipulation. And like I said, that could be a bunch of things. That could be a common denominator, some type of factoring. It could be, I'm trying to think of some other options here. It could be that you need to add some fractions together. There's a whole bunch of different things. But basically, anytime that you're trying to do some algebra stuff to kind of change how the trigonometry looks without actually like substituting something in. And then the big thing is look to use other identities, right? Sub, in, and identity. Okay? And then suppose like everything else fails. The worst case scenario option is just to convert everything to sine and cosine. Okay, so sine and cosine, because every single trig function can be written in terms of sine and cosine, one way or another. So today, hopefully, I'm going to help kind of teach you again how I would talk through these and how you could talk yourself through these same problems, okay? So I've actually purposely not looked at the answer key recently so that, I'm coming at it where I might even try one and then go, ooh, that's not the right way to do that, and try something else, okay? Because that is definitely going to happen. All right, so without further ado, here we go. So the first problem, the other thing you want to do is remember to pick a side, okay? In general, I try to pick the more complicated side and try to like clean that up because it's, in my opinion, more likely to work if you try the complex side and like pare it down. Anyway, so I look at, this very first problem and I notice that we have secant and then we also have cosine, okay? And so I'm going to say to myself, well, I know that secant and cosine are reciprocals of each other. So, that's definitely something you want to kind of keep in the back of your head. So I'm going to change, and in all honesty, it doesn't really matter what route you take. So just to make things look a little different, I'm going to change cosine to 1 over the secant of y. And I'm going to keep secant exactly how it is. And you wouldn't necessarily have to write this step, but just to make it really clear, we've got secant of y over secant of y, and that is going to cancel out and be 1. So 1 equals 1. Ta-da! Again, could you have just as easily flipped that to cosine? Yes, and that would have worked just fine. All right, sine squared over tangent squared equals cosine squared. Now, I could try to figure something out on the right-hand side and manipulate cosine squared, but usually it's easier to simplify a fraction. So I'm going to try and do that. Well, I need cosine squared. This is the other thing. You've got that perk of having the answer. So if I need cosine squared, I know I can't rewrite sine squared as cosine squared, so I'm going to leave sine squared alone. But I do know that tangent, if I rewrote tangent as sine over cosine, sine squared over cosine squared, it has a cosine squared in it. Okay, so that's the other thing you want to think about. Think about what do I want in my answer? How do I get that to show up in what I'm looking at right now? So I'm going to change the bottom half to be the fraction, sine squared over cosine squared. Okay, so I've done that, and now I've got this kind of funky looking fraction. But I can rewrite this if I think about the fact that I have a fraction within another fraction. I could rewrite this as the numerator, so sine squared over 1, times the reciprocal of the denominator, right? Multiply by the reciprocal. That's how you simplify fractions when you've got fractions within fractions. And now I have sine squared in the numerator and denominator, so those are gone. So I am left with cosine squared equals cosine squared. Don't forget your equal signs and your variables as you're working. Okay, so again, not necessarily the only way to go about that, but probably the most efficient way to do that. Okay. All right, number 3. Number 3 looks a little funky. It looks like I'm going to want to try the left-hand side. For sure, okay? And in a rare moment, we have 1 over secant on the right-hand side. So really, I'm trying to get a cosine. Okay, so I think the best course of action here when we've got 1, 2, 3 different trig functions is to convert everything to sine and cosine. So I'm going to change secant to 1 over cosine of x. And then I'm going to change tangent to sine of x over cosine of x. And then I'm going to keep the sign. Hopefully that's obvious because I want to keep everything in sine and cosine. And then this right here, I'm going to rewrite as one fraction. I'm going to multiply those together. So that's going to give me sine squared over cosine. Now sometimes, you know, students have asked me things like, well, how did you know to put those together? Well, I mean, I guess I don't know that that's always going to be the right way to go, but if you've got 2 fractions multiplied together, you should, if nothing cancels, then you should try and actually multiply them into 1 and see what happens, right? You're not going to break the math problem. So worst case scenario, I put it together and like that wasn't so great, and then I break it back apart. But in this case, check this out. We have a cosine in both, so we already have a common denominator. So not only did putting that fraction together clean up our problem a little bit, but now we have a common denominator, so I can take these 2 fractions and make them 1. So they're going to be over cosine of x, and then I've got 1 minus sine squared of x. Okay, and I got to carry my equal sign. Okay, remember you're equal to 1 over secant every single time. Okay, so I got to extend my page a little bit here, sorry. Well, 1 over cosine squared depends on how savvy you've become with our Pythagorean identities, but sine squared plus cosine squared equals 1. That's our main Pythagorean identity. If I move this sine squared over by subtracting it, since it's technically a positive over there, cosine squared is 1 minus sine squared. Okay? So that's a little like very common transformation of that identity. So the numerator in this case is really just cosine squared x over cosine of x. And that cosine, that exponent cancels because it cancels out with the cosine in the denominator. So we've got cosine of x equals, and cosine is 1 over secant. I would also like to point out that a lot of times, you know, there's like one key step that when you do it, then suddenly you see the domino effect of all the other steps you're going to need to take. But you're never sure where that step is going to come in. So that's why you just got to kind of play with it a little bit. Try things out. Okay, so those are our first 3 problems. 1 over secant. Beautiful. QED. For those of you quad erad demonstrata. For those of you Latin peeps, QED, there's your little classical connection. All right, we got a couple more problems to try. Okay, cotangent squared theta, and then secant squared theta minus 1. Multiplying those together. Well, we want this to equal 1. Well, we got a couple of different options. I would go, in this case, with the fact that everything is squared. Like all of our identities here are squared. So I'm thinking Pythagorean identity. So I think, okay, sine squared plus cosine squared. We just used that. That one's not going to help me very much. But the one where I divide by cosine squared. See, if you don't memorize them, you can still figure it out just by doing a quick little algebra step. Okay, so secant squared minus 1. That's going to be tangent squared. So this thing in the parentheses, that's really tangent squared, which is being multiplied by cotangent squared. Now, you know, okay, so if you are smart, and you totally are, you know that those are reciprocals of one another, but you got to show it. Even though you know it, you got to show it. That's the key thing about these identities. You got to show me what you know. So I'm going to change it. Really, it doesn't matter all that much. You just got to change one of them so that it very clearly is evident that those tangents cancel out and we are left with 1. And 1, as it does, equals 1. Ta-da! Not so bad. Now, you could have done that by distributing the cotangent squared or doing some other stuff, but it would have taken you like a lot more steps. Okay, that's the other thing. You know, there's a lot of different ways to do these, but some of them take a bunch of steps. Okay. Secant squared theta over tangent of theta. Well, this is the one when I looked at these, I went, this one I might try, and I might do something that doesn't work. Like, for example, I'll give you an example of what you could do that. Don't write this down. Just a little example of that doesn't work. We just saw that secant squared is tangent squared plus 1. So you could, you know, take the numerator and say, oh, tangent squared theta plus 1 over tangent of theta. And then you could say, okay, that's tangent squared over tangent plus 1 over tangent. And then you'd get tangent of theta plus cotangent of theta. Okay, here's the deal. That's not really helpful to this problem because right now I don't have secant or cosecant. So like all of that math I just did is true, but not going to help me because it's not going to get me to secant and cosecant. Secant and cosecant come from sine and cosine. So I need to find a way to push sine and cosine back into this problem. So what I'm going to do instead is I'm going to rewrite this as, you know, secant squared theta over 1 times 1 over tangent. Okay, I'm going to point out that, you know, the tangent's in the denominator and the secant squared's in the numerator. So then I'm going to rewrite my secant as 1 over cosine squared. And then I'm going to say, well, 1 over tangent is really cotangent. Again, lots of different ways we could approach this. Equals. And cotangent, 1 over cosine squared, sorry. Got to keep carrying that down. Cotangent is cosine over sine. All right, now I'm getting somewhere because this cosine is adios. And I'm left with 1 over cosine times 1 over sine. And those guys, those, and I just barely ran out of room, are secant, right? Those are thetas. Those are not my best thetas. My apologies. So we are done. But you kind of need, you know, to see this step right here where we split that up and kind of change it so we get all of our sines and cosines in order to make that happen. All right, I've got 1 minute to do this last problem. All right, again, this is one of those situations where you need to look at what you want in order to figure out what you need to plug in. So I'll say again, does it really matter what you plug in? No. You know what? Just because every other problem I've done the left-hand side, I'm going to do the right-hand side just to kind of show you that it doesn't really matter. Okay, 1 is sine squared plus cosine squared. And we've already got this minus 2 sine squared of y. All right. I mean, we don't do that substitution super often, but it can be done. 1 is that thing. All right. Looks like I'm pretty much done. And if you're like, how is that possible? Well, this is sine squared, and this is negative 2 sine squared. So that's like one of them minus 2. So we have cosine squared minus sine squared. Ta-da! And we're done. Bye.